Hi, this is the Science Chef. Welcome to the second part of our series on the 2023 JAMB Preparations. We continue with our solutions to the year 2017 JAMB UTME examination by making use of our newly acquired JAMB UTME CBT software. Let's start. We are starting from question 6. In our last video, we solved question 1 to 5. So if you'd like to see the solutions to the year 2017 JAMB UTME questions 1 to 5, check the link in the description. Okay, question 6. A mixture of chalk and water can be separated by A. Chromatography, B. Filtration, C. Separating funnel, D. Sieving. The mixture here to be separated is a mixture of chalk and water. Chalk, what are the properties of chalk? Chalk is insoluble in water. Chalk is insoluble in water. And the separation of a mixture makes use of the differences in the properties of the constituents of that mixture. Right? Now, what is a mixture? A mixture is any substance that contains two or more constituents that are not chemically combined, or that can be separated by physical means. So, whenever you have a mixture and you want to separate the mixture, you employ the difference or the differences in their properties, right? Now, water is a liquid. Water is a liquid, and not just a liquid, but a universal solvent. Water is a universal solvent, while chalk is a solid, right? A solid that is insoluble in water. Are we together? So, being insoluble in water, definitely it will not dissolve in the water, just like sand. So it will not, since it will not dissolve in the water, the best way to separate an insoluble solid from a from a liquid is filtration. That is B. So that's filtration, right? It cannot be chromatography because we are not dealing with colored substances, right? And neither can it be separating funnel, because separating funnel is used to separate immiscible liquids that have different densities, while sieving is used to separate solid particles of different sizes. So the answer here is filtration. So filtration. B. Next. Question 7. A physical change is A. Fermenting of sugar to ethanol, roasting of iron, C. Burning of paper, D. Dissolving sugar in water. What is a physical change? We have two types of changes in chemistry: a chemical change and a physical change. Now, what's the major difference, or what are the major differences? Now, a chemical change is not easily reversible. Remember, this is the key word: not easily. Chemical changes are not irreversible. Under suitable conditions, chemical changes are reversible, but they are not easily reversible. While physical changes, or a physical change is readily or easily reversible. Right? Then in a physical change, no new substance is formed. No new substance is formed, whereas in a chemical change, new substances are formed. Fine. So, which means that for a chemical change, the old substance, right, or the reacting substance will fade away and a new substance will emerge, right? Whereas in physical change, the substance will remain the same, right? The constituent of that substance will remain the same. Yes, it may undergo a change in state, maybe from solid to liquid, but the same constituent, the liquid component or the solid component of that substance will be the same. Example: ice and water. Ice contains H2O, while water also contains H2O. So there's no change. When ice melts or water freezes, no new substance is formed. And because no new substance is formed, there'll be no change in mass for physical change. Whereas in a chemical change, there'll always be a change in mass. So these are some of the few differences between chemical changes and physical changes. There are more than this. I think there are about 4 or 5. So now, from these options given to us, which of these options, 1 is not easily reversible, and 2 is a new substance formed, or no new substance is formed? Since we are looking at physical change, it means that no new substance will be what formed. In other words, you can easily get back what you started with. Let's see, fermenting sugar to ethanol, fermentation of sugar to ethanol, that is glucose C6H12O6 in the presence of what? Yeast, to give us what? CO2 and C2H5OH 2, right? Now this is your glucose or your sugar, this is carbon dioxide, this is your what? Ethanol. So what happens here? In the presence of microorganisms, in the presence of yeast, glucose is converted to what? Ethanol. This is the equation for what? Fermentation. Ethanol is completely different from glucose. So a new substance is what? Formed. The glucose is what? Lost, right? And this process is not easily what? Reversible. So this is a chemical what? Change. Now, rusting of iron. Rust is hydrated iron 3 oxide. So when iron reacts with oxygen in the presence of what? Water, it forms what? Rust, a new substance. And this rust has a different property from what? From iron. Rust is a compound, is a hydrated compound, whereas iron is a metal. So there are two different substances, right? So rusting of iron is a chemical change, because this rusting of iron cannot be easily what? Reversed. That's why once your iron undergoes rusting, the only thing you can do is to what? Change that iron or replace it. You cannot reverse that rusting what? Process, because it's a chemical what? Change. Then likewise, burning of paper. Paper contains cellulose, that's carbohydrate. That contains carbon, hydrogen, and what? Oxygen. So when this undergoes what? Combustion in presence of oxygen, it will form what? Carbon dioxide and what? Water, right? Carbon dioxide and water are two different substances, completely different from what? The starting material, that is cellulose, right? So in this case, since new substances are formed, it means that the burning of paper is a chemical what? Change, because it cannot be easily what? Reversed, right? Now, the last option, dissolving sugar in water. When you dissolve your sugar in water, you get sugar solution. Can you get by your sugar from that solution? Yes. If you carry out what? Crystallization. If you crystallize that sugar solution, you get back your sugar, right? Or if you carry out a form of distillation, you can get back your water and your what? Sugar. So that means that no new substance was actually what? Formed. There was no chemical what? Combination in the process, right? It was just a mixture of two different what? Constituents, which can be separated by physical what? Means. So dissolution of sugar in water is a physical what? Change. And the answer here is what? D. Alright, next. Question 8. Chemical equilibrium is based on A. Equality of the rates of the forward and reverse reaction. B. The quality of the forward and reverse reaction. C. The conditions of two opposing reactions. D. The rates of two opposing reactions. So chemical equilibrium is the condition at which the rate of the forward reaction of a given reaction equals the rate of the backward what? Reaction, and it's always represented with a sign of what? Reversibility. Now the sign of reversibility, that's double arrows, double equal arrows, not something like this. Yes, this is a reversible arrow, but this does not represent what? Equilibrium. For it to be equilibrium, the forward arrow and the backward arrow must be what? Equal, which signifies that the rates of the forward and backward reactions are what? Equal. So let's say we have reactants A and B giving us what? C and what? D. Now these are two different equations, right? That's A and B giving us C and D, and C and D giving us what? A and B. Well, this is the backward reaction, this is the forward reaction. So at equilibrium, right, let's call this RF and this one RB. At equilibrium, the rate of the forward reaction equals to the rate of the what? Backward reaction, not the forward reaction being equal to the backward reaction? No, but the rate of the forward reaction must be equal to the rate of the backward reaction. Another condition for chemical equilibrium is that at equilibrium, the concentrations of the reactants and products will not change, right? There will be no change in the concentrations of the product and what reactants. Their concentration will remain what? Constant, but not necessarily what? Equal. They may be equal, right? But the certain thing is that their concentrations will not change over a period of what? Time. So that's how you identify a reaction at equilibrium. So given that explanation, which of these options fits that explanation? The equality of the rates of the forward and reverse reaction. That's chemical equilibrium is based on the quality of the rates of the forward and backward or reverse reaction. Okay, that sounds correct. Let's see the other options first. Remember, this is JAMB, so you have to go through all the options first before picking the appropriate what? Answer. Because JAMB has a way of making two or more answers look what? Similar. Right? Now look at this, the second question. The quality of the forward and reverse reactions. Can you see? The quality of the forward and reverse reaction. If you are not careful, if you don't take the rates into consideration, you might go for option B, right? Which is not correct, because we're not looking at just the forward and reverse reaction, but their rates, the rates of the forward and reverse reactions must be what? Equal. Now the C says the conditions of two opposing reactions. No, that's not chemical equilibrium. That's more like a redox what? Reaction, two opposing yet complementary what? Reactions or processes. Then D, the rate of two opposing reactions. No, the rate of two opposing reactions. How? It's vague, right? But here we are told that the equality of the rates of the forward and reverse what? Reaction. Yes, the reactions may be opposing, but their rates may not be what? Equal. So as far as the rates are not equal, just like this, right? Just like that, the system has not attained chemical equilibrium yet, right? So for that system to attain a chemical equilibrium, the rates of the forward and backward reactions must be equal. And the correct answer to this question is what? A. Question 9. Wow. Another question on chemical equilibrium. The equilibrium constant for the above reaction at constant temperature is this. So tiny. This is what we have there. That's A of A gas, A moles of gas A plus B moles of gas B, giving us X moles of solid C plus H moles of gas what? H plus Y moles of gas H, sorry. So now, in writing the equilibrium constant of a given equilibrium reaction, right, make use of the aqueous and gaseous what? Species in the equation of reaction, right? We don't include the solid and liquid what? Species, because it is assumed that the concentration of solids and pure liquids do not change, right? So equilibrium constant concentration of this reaction, that's Kc, will be what? The concentration of H raised to power what? Y. Why are we using H? Because H is a gas, right? And we are not using C here. All over what? The concentration of A raised to power what? Small a times the concentration of B, gas B raised to power what? Small b, right? We are not including or adding the concentration of C in this expression because C is a what? Solid. Now, generally, to write the equilibrium constant of concentration as for a given equilibrium reaction, we use the word, the concentration of the product raised to the power of their stoichiometric what? Values in the equation of reaction divided by what? Divided by the concentration of the what? Reactant raised to the power of the stoichiometric what? But provided that the products and the reactants used in this expression are not liquids nor solids. So based on what we have here, what will be the correct answer here? That should be C. Our last question for today. Which of the following substances will decompose when an electric current is passed through it? Now, for a substance to decompose when an electric current passes through it, it means that that substance must be what? An electrolyte. Because yes, even though it would be a conductor, or if it is a conductor in the solid state like metal or like graphite, they will not decompose, right? Solid conductors do not decompose. It is only electrolytic what? Conductors that decompose when an electric current is passed through them, right? And for a substance to act as an electrolyte, right? What is an electrolyte in the first place? An electrolyte is an ionic compound which allows direct current to pass through it in its molten state or aqueous what? Solution, and gets decomposed in the what? Process. That is an electrolyte. And it does not just allow current to pass through it, it gets decomposed what? In the process. And why does it allow current to pass through it? Because of its mobile what? Ions. Its mobile ions enables it what? To conduct electricity, to carry charges from one point to what? Another. Electrolytes only conduct electricity in the aqueous what? Solution or molten what? State. They cannot conduct electricity in the solid state. Why? Because in the solid state, the ions are not free to move about. That's why you are told that electrolytes conduct electricity with the help of what? Mobile ions and not electrons. They don't conduct electricity with electrons. Take note of that, because that's the mistake students always make. Which means that for the substance to be an electrolyte, it must be made up of what? Ions, right? It must be an aggregate of what? Ions. So which of these substances is or are aggregates of what? Ions, right? Okay, which of these is an aggregate of what? Ions? Let's see. Sucrose. Sucrose solution, that's sugar, C12H22O11. This is an organic compound. Sugar is an organic compound, and being an organic compound, it is not ionic, right? Sugar does not contain ions, and so it cannot produce any ions in solution, so it will not conduct what? Electricity. Then copper rod. This is copper rod, Cu. Now copper is a metal, right? And as metals conduct electricity with the help of what? Mobile electrons. Metal conducts electricity with what? Mobile electrons. You may need to watch our video on the properties of aluminum to see how metals conduct electricity with the help of mobile what? Electrons, right? We had illustrated that in that video, right? And we also explained the structure of the metallic what? Lattice in that what? Video. I will add the link in the description. Now phase 6 solution, that is H2SO4. H2SO4, yes, even though it contains non-metals, right? But in solution, it will do what? Ionize to give us what? Hydrogen ion and what? Tetrasulfate 6 what? Ions, which are responsible for its ability to conduct what? Electricity in what? Solution. But let's look at the next one before we conclude. Methylated spirit. Methylated spirit is mainly what? Ethanol plus a bit of what? Methanol. That is CH3OH. Now, they do not contain ions, even though they contain some level of what? Polarity, but they do not contain full ions like H2SO4. So there's no way they can conduct what? Electricity. So the correct answer to this question is what? C. Tetrasulfate 6 acid. This tells us that all acids are electrolytes, right? We have strong acids and weak acids. Strong acids are strong electrolytes, while weak acids are weak electrolytes. Likewise, strong alkalis or strong bases and weak bases, right? Or weak alkalis. Strong alkalis are also strong electrolytes, while weak alkalis are weak electrolytes. Strong electrolytes undergo complete ionization in water, while weak electrolytes undergo partial ionization in what? Water. Almost all salts, if not all, are all what? Strong what? Electrolytes. Because salts, for a substance to qualify as a salt, must contain metallic ions and non-metallic what? Radicals. Are we together? So salts are also what? Good what? Electrolyte. So the correct answer to this question is what? Tetrasulfate 6 solution. That's tetrasulfate 6 acid what? Solution, which is C. So let's pick our option C. So that brings us to the end of the second part of our series on the 2023 JAMB preparation, right? So if you had gained any value from this video, kindly drop a comment and hit the like buttons, right? And also, if this is your first time, if you are yet to subscribe and turn on your notification bell to always stay updated with the new upload. So until then, shoot for the sun so that if you miss, you fall among the stars. Until I see you when I see you.